In this video, we're going to keep talking about 1.5. We're going to talk about the second objective of finding limits numerically. And I'm going to start with problem number 5 from the textbook, which says to find the limit as x approaches 6 of 2x plus 3 over 5. I'm going to show you how to do that with the graphing calculator. This is equivalent to you doing all these calculations by hand. I'm just going to save you some manual tabulation. So when you go into your y equals here, you want to type in 2x plus 3 in the numerator. That's going to be divided by 5. The easiest way to do that is with parentheses, 2x plus 3 for the numerator divided by 5. We don't need the graph here, but we do need to go to the table settings here and make sure our independent variable is set to ask. And then we want to go to our table, and I'm going to delete the options out of here that I have. I'm going to draw a rough sketch of the f of x table that they gave us in the book, where this says x and this says f of x. And we're told to use 5.9 and 5.99 and 5.999. And then at 6, we want to find out what's going on. And then we have 6.001, 6.01, and 6.1. And so those are our 6 values that we're going to use to see the behavior coming from the left and the right. So I'm going to type in 5.9 and I get 2.96. And I'm going to type in 5.99 and I get 2.996. And then 5.999 and I get 2.9996. So I got a pretty good idea what's going on there. Let's go ahead and let's come from the right. 6.1 is 3.04. 6.01 is 3.004, and 6.001 is 3.0004. So it sure looks like that this is squeezing in on 3, and it is. So my limit as x approaches 6 of 2x plus 3 over 5 is 3, and we found that with our table. Let's go ahead and let's look at number 7 here. And it says got cut off on my paper. Let me go ahead and look at that again. 0.5 exercises. Number 7 says the limit as x approaches 4 of x minus 4 over x squared minus 5x plus 4. Okay, so we're going to have another table here. Bring this down a little bit here of f of x values, and this table starts at 3.9, then 3.99, then 3.999, Then at 4, we want to see what's going on. This is 4.001, 4.01, 4.1. So I'm going to change my equation here, and I have a numerator of x minus 4 and a denominator of x squared minus 5x plus 4. Both of those get wrapped in parentheses. I go to my table, and coming from the left, 3.9 is, it's a lot of decimal places. So I'm going to just go to a few decimal places here. It's about 0.345, 3.99 is 0.334, 3.999 is 0.3334, and I have a suspicion what that's coming in on there. Let's come from the right now. 4.1 is about 0.3226. Let me go back and look at 3.9 again to 4 decimal places. 3448. And this is 3344. 4. Okay, and then 4.01 is 0.3322, and 4.001. And technology is just really helpful to make you not have to do these nasty calculations with decimals by hand. So I'm sure your teacher is going to want you to do this the same way. 332. And the right answer is right here in between these numbers. You may think it's 0.3333, and that's really close to it, but it's actually 0.3 repeating over and over again. So it's the right answer is 0.3 repeating, which is the decimal equivalent of 1/3. And I'm going to show you this leads into the idea in the next section that we can find these limits without the table method using some other techniques. But if I factored the top and the bottom here, then factors of 4 that add up to be -5 are -1 and -4. So that common factor cancels and leaves me with the limit. I need to keep my limit symbol here as x approaches 4. Limit as x approaches 4 of 1 over x minus 1, and then I can stick the 4 in there. 1 over 4 minus 1 is 3, and that is equal to 0.3 repeating, or you can express it as 0.3333, and just a ... after it to say the 3's just keep right on going forever and ever. So it would be really close to the right answer, and your teacher would probably accept it at this point if you got close with 0.3333. But the most accurate answer is to say that it's 1/3, as we can express that repeating decimal as a fraction exactly. We can't express it as decimal without what's called a repetenbar here to show the repeating decimal, or without the ellipses here. And WebAssign is not going to like either of those. It's going to like you to give the fractional answer. You're probably going to be doing these problems in WebAssign. All right, so that's it for this video, and we'll come back next time and we'll start to evaluate some basic limits using some of the rules and things, one of them being the factoring technique that I just talked about. So I'll see you for the next video.